In this video, I'm going to show you guys how you can make this pretty cool Arduino thermometer for your room. All you really need to make it is your Arduino board, a DHT11 heat and humidity sensor, some male-to-male jumper wires, and a 10,000 ohm potentiometer. So I'm going to go ahead and model this in Tinkercad. Tinkercad doesn't have a DHT11 or an Arduino Nano, so I'm going to be using an Uno and a TMP36, I guess. So this temperature sensor is actually pretty similar to the DHT11 with its three values here: ground, input, and or ground, signal, and 5V. But the actual signals on a different pin, and the signal and the voltage is switched. So the power should be in the middle and the signal should be on the far left, but ground is actually in the right spot. Ground is where it should be. Well, ground is the same for both. And the Uno, like any Arduino board, it's going to be the same. Just, you can connect the same pins, but I'm just using the Uno as it's the only one in Tinkercad. Alright, so we'll start off with this LCD. So we're gonna oh, actually first let's start off with ground and voltage. So we're gonna connect our ground. So our ground here, actually connected up here. So our ground here, and we'll make this blue, and our voltage here, we'll make this red. And we don't need to actually make these two lines electrically common, or these two rows electrically common, as this one is going to remain unused. And we're going to start connecting our ground and voltage on our LCD. So obviously the ground, or on your LCD, it might be, I'm just gonna make that straight. So on your LCD, this might be VSS and VDD, but it's the same as what's on here. So we're gonna set our ground. So we'll make all our grounds blue. So we're gonna make our ground here. So that's a ground connection. Another ground connection is the RW. And this last connection here is also a ground connection. So those are three ground connections for the LCD board, or the LCD display. Then for our power, we're gonna connect our VCC or VDD on mine, and that's the only power connection on the LCD display. And now we're gonna start connecting our pins to our LCD to the Arduino. So I'm going to start going from right to left. So our anode connection goes to our digital pin 9. So our anode is digital pin 9. So I'll go ahead and be here. See how our digital pin 9, we'll make this green. Digital pin 9, we connect here. And then our digital pin 7, DB7. I don't know if it's a digital pin, I'm just calling it a digital pin. But our DB7, check. Anyways, so we have our D7 pin. So our D7 is connected to the digital pin 2 on our Arduino. So I'll switch the color here to orange. And we gotta find 2. And we'll actually connect that to 7. Alright. Now we're gonna do our 6. So our 6th is connected to digital pin 3. So go ahead and do that. So we'll switch our color maybe to yellow. So digital pin 3 to 6. Our digital pin 5 is connected to our D5 is connected to digital pin 4. So we'll go here. Our D5 is connected to digital pin 4, and our digital pin 4, or not our digital pin 4, our D4 on our LCD is connected to digital pin 6. So, well, I don't know, set this back to green. So our D4 on our LCD is connected to digital pin 5, So digital pin 5 over here, we'll connect that to D4. Okay, so now these can be left empty, because those 3 are left empty. And now we will connect our VO, RS, and E. So VO is connected to the wiper pin on your potentiometer. So I'll make that brown. VO will connect to our wiper. RS is connected to our digital pin 13. So I'll turn this back to gray, maybe. I'll turn this to gray. And we'll set our RS value, or register select, and our E, or our enable, is connected to digital pin 10 on our Arduino board. So digital pin 10. Alright, so now our LCD is completely set up. D0, 1, 2, and 3 not being unused, remaining unused. And now we'll connect our fake DHT11 and our potentiometer. So I'll start off with the potentiometer. So basically, this terminal 1 and terminal 2, one just has to be connected to ground, the other one just has to be connected to voltage. So it's pretty simple. We'll connect one to our voltage and this other one to our ground. and this voltage one I will turn red. So now we have to connect our sensor. So this one is not a DHT11 like I said. So imagining it was a DHT11, this leftmost pin would be a signal pin, which would be connected to digital pin 7, and the signal pin here, or let me this up, and the actual signal pin here would be our digital pin here would be our voltage, because we are switching our voltage and our ground. So we'll change this to voltage, or we'll switch this on to voltage, and then we'll put this and we'll put this on our ground, and that's it. Everything is set up now, and you can go upload the code. So going over the code, in the first two lines we are including the libraries, so the liquid crystal library and the DHT, so the humidity and temperature library. And you actually have to go to tools. No, not tools. You go to tools, manage libraries. That was already open for me. But you go to tools, manage libraries, and you can actually download the libraries you need. So I'll put the names of them on the screen, but back to the actual code. So we include our libraries, then we define the sensor type and which pin it's going to be a part of, or which pin it's connected to, the output pin. Once you do that, you actually create the object for the LCD and the DHT using the pins that were used on the breadboard, and then the two values that were assigned on top. And then you put the integer or the pin you use for the backlight of the LCD. You could use a constant or int or a regular int. Oh, I have caps lock on. It's not really, it doesn't really matter because you're not really changing this value in the code. So, and then we have the two temperature values, the previous temperature and the current temperature. So in our setup menu we have our beginning. So we initialize the sensors and the LCD display, the sensor and the LCD display, and we set our pin modes and we set our analog right in our pin mode. So we set our backlight pin output, and then we set its value to 255. Now in our loop, we have a delay of 2000 milliseconds or 2 seconds. That delays the time that it takes between readings. So it'll read, wait 2 seconds, read again. So we set our temperature value to the value taken in by the sensor. We set the LCD cursor to the first column and the first section, or the first row and first column. We clear the LCD, then we print the temperature. Well, we print temp, and then the actual temperature value. And then this one goes for changing the temperature. So if the current temperature is not equal to the previous temperature. So if the temperature changed, then it resets the LCD, and then it prints updating for 1 second, and then it updates the temperature right here. So previous temperature is equal to the current temperature, and then it rewrites over here.